The universe is vast, mysterious, and full of wonders that challenge our understanding of reality. Beyond the stars and galaxies, we can observe lies an unseen realm, shrouded in mystery and speculation. In this video, we journey through the boundaries of the observable universe, exploring the forces that shape it and the possibilities that extend far beyond our current reach. Join us as we delve into the profound depths of existence and uncover what lies beyond the visible cosmos. Imagine embarking on an endless journey through the cosmos aboard a spaceship, traveling faster than anything ever created. How far would it take you, and what would you encounter? Could you ever reach the edge of the universe? And if so, what lies beyond? These are questions that have fascinated humanity for centuries. We'll delve into the mysteries of the observable universe, exploring its boundaries, the possibilities beyond, and what this means for our understanding of existence. Let's begin with the observable universe, defined by the limits of how far light has traveled since the Big Bang. It spans a staggering 93 billion light-years across. The light we see from distant galaxies started its journey billions of years ago, showing us not their current state, but what they looked like in the past. This boundary is not fixed. Cosmic expansion, driven by dark energy, continually shifts the edges of what we can observe. Recent observations, including those from the James Webb Space Telescope, JWST, have provided astonishing insights. A groundbreaking discovery of ancient galaxies challenged our understanding of cosmic evolution. These galaxies, formed 600 million years after the Big Bang, appeared impossibly massive, forcing scientists to question if the universe might be far older than the widely accepted 13.8 billion years. Now let's explore some compelling questions. Is the universe infinite or finite? If infinite, what does this mean for its structure? If finite, where does it end? What role do dark energy and cosmic expansion play in shaping what lies beyond? These mysteries have profound implications, challenging the very fabric of physics and cosmology. As we examine these questions, let's first understand what the edge of the observable universe signifies. This boundary is not a physical edge, but a horizon, the farthest point from which light has had time to reach us since the Big Bang. Beyond this horizon, the universe continues, but its details remain hidden. Dark energy, an enigmatic force constituting about 68% of the universe, accelerates this expansion, pushing galaxies beyond our view. One fascinating thought experiment is imagining a spaceship traveling at near light speeds. According to Einstein's theory of relativity, time aboard the ship would slow relative to an outside observer. While it might seem possible to reach distant galaxies within the ship's timeline, the cosmic expansion ensures many destinations remain forever out of reach. Galaxies currently visible to us will, in billions of years, fade from sight as space itself expands faster than light. Consider the galaxy GN-Z11, one of the most distant galaxies ever observed. At a distance of 32 billion light-years, it represents a snapshot of the universe when it was only 400 million years old. Yet, even as we study it, GN-Z11 moves away at a velocity exceedingly twice the speed of light. Its current state, along with countless other galaxies, will forever remain inaccessible. If the observable universe is like a bubble, what lies outside this bubble? Some theories suggest that beyond the observable horizon lies an extension of the same cosmic structure we know, a continuation of galaxies, dark matter, and dark energy. Others propose a multiverse, a collection of universes with differing physical laws, dimensions, and constants. This idea, rooted in string theory and quantum mechanics, is as speculative as it is tantalizing. The concept of an infinite universe is one of the most fascinating and perplexing ideas in modern cosmology. If the cosmos truly extends forever, then it follows that every possible configuration of matter must exist somewhere within this boundless expanse. This notion stems from the laws of probability and the finite number of ways particles can arrange themselves in a given space. Over infinite distances, these arrangements would inevitably repeat, creating what can only be described as infinite duplicates of everything, including Earth and its inhabitants. To understand this, imagine the universe as a vast cosmic library filled with an infinite number of books. Each book represents a unique arrangement of particles, stars, planets, and even life forms. In an infinite library, every possible story must exist, from minor variations of familiar tales to completely different narratives. Applied to the universe, this means that somewhere out there could be exact replicas of Earth, where the history of humanity has unfolded in precisely the same way as it has here. Beyond that, there could be Earth-like planets where events diverge at critical points, creating alternate histories and realities. This idea, while mind-bending, arises naturally from the combination of cosmic inflation theory and the observable evidence of the universe's structure. Inflation suggests that the universe underwent a period of rapid expansion shortly after the Big Bang, resulting in a vast, possibly infinite expanse of space-time. Within this framework, our observable universe is merely a small region of a much larger whole, a bubble within an endless froth of other cosmic bubbles. If inflation is correct, it implies that there are countless regions of space beyond what we can observe, each containing its own configurations of matter and energy. The implications of infinite duplicates are profound. It challenges the notion of uniqueness and individuality, suggesting that everything we know and experience might not be as singular as we believe. For instance, there could be an identical version of you, living on an Earth indistinguishable from ours, pondering the same questions about existence. The distances separating these duplicates would be astronomically vast, far beyond the reach of any conceivable technology, but their existence would still be a mathematical certainty within an infinite framework. This concept also raises philosophical and existential questions. If there are countless duplicates of Earth and its inhabitants, does this diminish the significance of our existence? Some might argue that it makes our world feel less special, while others see it as a testament to the vastness and grandeur of the cosmos. It could also provide comfort, as it suggests that every possible version of life, including ones where certain mistakes were avoided or different choices were made, exists somewhere in the universe. Critically, the idea of infinite duplicates remains speculative, hinging on the assumption that the universe is infinite and follows the same physical laws throughout. While current observations suggest that the universe is flat and potentially infinite, definitive proof remains elusive. Nevertheless, the concept continues to captivate scientists and philosophers alike, offering a glimpse into the unimaginable scale and diversity of the cosmos. To understand these possibilities, let's delve into the universe's shape. Is it flat, spherical, or something even more exotic? Observations suggest that, on a large scale, the universe appears flat, with parallel lines never converging. However, it may also be closed in higher dimensions, much like the surface of a sphere is two-dimensional, but curves into three-dimensional space. If true, traveling far enough in one direction could theoretically bring you back to your starting point. Another mind-expanding idea is the multiverse hypothesis, where our universe is one of countless others, each with unique properties. This theory arises naturally from inflationary cosmology, which describes the rapid expansion of space-time fractions of a second after the Big Bang. Some regions of this inflating space might have developed into separate pocket universes, each isolated from the others. Dark energy, the mysterious force driving the accelerating expansion of the universe, represents one of the most significant enigmas in modern cosmology. Though it constitutes about 68% of the universe's total energy, its exact nature remains elusive. What is clear, however, is its profound impact on the cosmic structure and the ultimate fate of the universe. By pushing galaxies apart at an ever-increasing rate, dark energy is reshaping the cosmos in ways that challenge our understanding of time, space, and the very fabric of reality. As galaxies continue to move away from each other, the distances between them grow exponentially, fundamentally altering the observable universe. In the distant future, billions of years from now, this acceleration will push the majority of galaxies beyond our observable horizon. This means that the light emitted by these galaxies will never reach us, effectively rendering them invisible. What remains within our observable universe will be limited to a small cluster of nearby galaxies, likely dominated by the local group, which includes the Milky Way, Andromeda, and a few dozen smaller galaxies. Over time, even these galaxies will undergo significant changes. Within this shrinking observable universe, the life cycle of stars will play out, leading to a gradual dimming of cosmic light. Stars like the Sun will exhaust their nuclear fuel, evolving into white dwarfs, neutron stars, or black holes. More massive stars will end in supernova explosions, seeding the surrounding space with heavy elements but leaving behind compact remnants such as black holes. Eventually, even these remnants will face their demise. According to Hawking radiation theory, black holes emit tiny amounts of radiation, causing them to lose mass over immense timescales. This process, though extraordinarily slow, will ultimately result in the evaporation of all black holes, leaving the universe devoid of any luminous objects. The far future of the universe, often referred to as the heat death or big freeze, envisions a cold, dark expanse. With no new sources of energy, the cosmos will reach a state of maximum entropy, where matter and energy are evenly distributed, and no work can be performed. The universe at this stage will be dominated by low-energy photons and neutrinos, with temperatures approaching absolute zero. This grim scenario paints a picture of a universe that is static, lifeless, and unchanging. However, the story does not necessarily end there. Quantum mechanics, the branch of physics governing the behavior of particles on the smallest scales, introduces the intriguing concept of vacuum fluctuations. In the quantum vacuum, particles and antiparticles can spontaneously appear and annihilate in a process that defies classical intuition. These fluctuations are not random, but rather governed by the probabilistic rules of quantum theory, and they occur even in the absence of matter or energy. In the context of an infinite universe, the concept of vacuum fluctuations introduces possibilities that challenge conventional understanding. These fluctuations, a well-established phenomenon in quantum mechanics, involve the spontaneous appearance and annihilation of particle-antiparticle pairs in a vacuum. While they are typically fleeting and occur on minuscule scales, the implications of these fluctuations in the vastness of the cosmos are profound. suggesting that even the most desolate regions of space are teeming with potential. In laboratory settings, vacuum fluctuations have been indirectly observed through phenomena like the Casimir effect, where two closely placed plates experience an attractive force due to the energy of the vacuum between them. This experimental confirmation underscores that empty space is not truly empty. Instead, it is a seething quantum field capable of generating transient particles. Extrapolating this concept to the scale of the universe, these fluctuations could result in remarkable cosmic phenomena, especially over astronomically long timescales. The vast expanse of an infinite universe provides the stage for these fluctuations to manifest in ways that transcend the microscopic scale. Given enough time, quantum fluctuations could theoretically lead to the spontaneous formation of particles and matter, potentially coalescing into entire star systems, galaxies, or even entirely new universes. This idea, though speculative, aligns with the concept of a dynamic cosmos, a universe not fixed in its current state, but one that evolves and transforms endlessly. For instance, in regions of space where matter is sparse, vacuum fluctuations could initiate the creation of small amounts of matter, which through gravitational interactions might accumulate over billions of years. In this scenario, a single quantum fluctuation could eventually snowball into the birth of a star or even a galaxy. These new structures could reignite regions of the cosmos that were previously cold and dark, illustrating the regenerative potential of the universe. Moreover, in the framework of eternal inflation, quantum fluctuations are theorized to play a pivotal role in the creation of pocket universes. This theory suggests that while our observable universe continues to expand, isolated regions of space-time could experience localized bursts of inflation, giving rise to separate, self-contained universes. Each of these pocket universes might have its own set of physical laws and constants, contributing to a multiverse of infinite diversity. This potential for vacuum fluctuations to drive cosmic regeneration highlights the dynamic and unpredictable nature of the universe. Far from being a static, lifeless expanse, the cosmos may be in a constant state of flux, with creation and transformation occurring on scales far beyond human comprehension. This perspective reshapes our understanding of what it means to exist within an infinite universe, suggesting that even in the vast emptiness of space, the seeds of creation are always present. Ultimately, while these ideas remain theoretical, they underscore the boundless potential of the universe to reinvent itself. Through the lens of quantum mechanics, the cosmos transforms from a static backdrop to a vibrant, ever-changing entity, offering infinite opportunities for discovery and wonder. The idea of spontaneous universe formation is closely tied to the concept of eternal inflation, a theory suggesting that the rapid expansion that occurred just after the Big Bang continues in isolated pockets of the cosmos. These pockets, or bubble universes, could form through quantum fluctuations in the vacuum of space. Each bubble universe may have its own physical laws and constants, creating a multiverse with an almost unimaginable diversity of possibilities. If these processes are real, they would fundamentally alter our understanding of the universe's fate. Rather than an endpoint marked by darkness and entropy, the cosmos might be part of a cyclical process where new regions of space-time emerge, evolve, and give rise to entirely new realities. This would mean that even in the most desolate and long-term scenarios, the universe retains a boundless capacity for renewal and creativity. This interplay between dark energy and quantum mechanics also raises profound philosophical and scientific questions. If the universe is infinite, both in space and time, what does that imply about the nature of existence? Does the universe have a purpose, or is it an endless cycle of creation and dissolution? While these questions may never be fully answered, they underscore the depth of human curiosity and our drive to explore the unknown. Furthermore, understanding these processes could have practical implications for science and technology. Quantum fluctuations are not merely theoretical. They form the basis for phenomena such as the Casimir effect, where two uncharged plates in a vacuum experience an attractive force due to the energy of the vacuum itself. Harnessing these principles could revolutionize fields like energy production, computing, and materials science, offering a glimpse of how cosmic mysteries could shape our future. Returning to dark energy, its role in driving the accelerating expansion of space also forces us to reconsider the nature of gravity and the universe's fundamental forces. Einstein's general theory of relativity describes gravity as the curvature of space-time caused by mass and energy. Dark energy, however, acts in opposition to this curvature, pushing space-time apart rather than pulling it together. This has led some scientists to propose modifications to general relativity or entirely new frameworks for understanding gravity, such as string theory or quantum gravity. The mysterious nature of dark energy also invites speculation about its origin. Some theories suggest it could be a property of the vacuum itself, while others posit that it arises from unknown fields or particles. The search for answers continues, with advanced observatories like the Euclid Space Telescope and the Nancy Grace Roman Space Telescope aiming to map the universe's expansion and uncover clues about dark energy's properties. As we piece together the puzzle of the universe's ultimate fate, one thing becomes clear. The cosmos is far stranger and more complex than we can imagine. From the accelerating expansion driven by dark energy to the potential for quantum fluctuations to create new universes, every discovery reveals layers of mystery that challenge our understanding of reality. In exploring the edge of the universe, we also confront its beginning. The Big Bang is not just a singular event, but a continuous expansion that created space-time itself. As we probe further into this mystery, instruments like the James Webb Space Telescope provide unprecedented views of the universe's infancy. By studying ancient light, scientists hope to unravel the secrets of the first stars, galaxies, and the mysterious substance known as dark matter. This journey raises profound philosophical questions. If the universe is infinite, does it render humanity insignificant? Or does our capacity to ponder these vast mysteries elevate our existence? Each discovery about the cosmos reshapes our understanding, offering glimpses into the profound interconnectedness of all things. The observable universe is both a boundary and a window, a limit to what we can see, but a glimpse into the vast, uncharted territories beyond. Whether through the exploration of dark energy, the mysteries of quantum mechanics, or the search for a multiverse, humanity's quest to understand the cosmos is far from over. Each step forward not only reveals the grandeur of the universe, but also deepens the mystery of our place within it. The universe's observable boundaries are not limitations of the cosmos itself, but of our current ability to perceive it. Light from distant galaxies takes billions of years to reach us, meaning we are observing the universe as it was in the distant past. Beyond this observable horizon, space likely continues, potentially infinitely, filled with galaxies and phenomena that mirror or vastly differ from the structures we know. What lies beyond, whether it is more of the same, an entirely different physical reality, or even a multiverse of parallel universes, represents one of the most profound mysteries of our time. Exploring the unknown is intrinsic to the human spirit. The thought that there may be regions of space where time and physics operate differently, or even where life exists under conditions we cannot yet fathom, inspires both scientists and dreamers. It pushes us to innovate, to build more powerful telescopes, and to refine theories of the universe's structure and origins. From probing the possibilities of dark energy to exploring the implications of quantum fluctuations, each step brings us closer to understanding the infinite possibilities that lie beyond. The mystery of what lies beyond the observable universe also serves as a humbling reminder of our place in the cosmos. Earth, a small planet orbiting an unremarkable star in the vastness of space, is a precious anomaly in a seemingly endless expanse. Yet, it is from this small blue dot that humanity has dared to ask questions about the infinite. The search for what lies beyond is not just a scientific endeavor, but a testament to our collective curiosity and imagination, a drive to seek meaning and connection in an incomprehensibly vast universe. Share your thoughts with us in the comments below. If you found this journey through the mysteries of the universe fascinating, don't forget to like, share, and subscribe for more captivating content. Thanks for watching, and we'll see you in the next video.